In this example, we're going to try a series to solve the differential equations. This is by no means guaranteed to work, by the way. It may give us some idea of what the solution is. We may be able to recognize the result as some function that we know, or we may not. It's just an attempt to try to understand the solution a little better than we do just by looking at the equation. So this is the equation. The derivative of f with respect to x is x cubed times f, and plus x cubed times f is equal to 2. And when x is 0, we want the function to be 5. Okay, great. So we're going to try a series solution. The derivative is, again, gives us another series. And so the original equation says that the series we get from the derivative plus x cubed times the series that we have for the function is equal to 2. Now notice this power here will actually start when n is equal to 1, the power will be 0. This power here will actually start with the power 3, because when n is 0, we are still multiplying c0 by x cubed. So let's put those together in a way that shows us keeps the same power for every term in x, and then we can see what this actually says. I've rewritten the equation so that k is the power of x in both terms, and so this one starts with k equal to 0, and the coefficient is k plus 1 c sub k plus 1. Remember, this came from the derivative, and so the first term is 1 times c1 times x to the 0. This came from x cubed times f, and so we're starting with k equal to 3 as the lowest power of x, and the coefficient is c0 when k is equal to 3, c0 times x cubed, and that's correct as well. And the right hand side was just the number 2, so only the 0th power. So when we're looking at the 0th power, on the left we have c1 is the constant coefficient, and on the right we have 2, so c1 has to be equal to 2. If we look at k equal to 1, on the left we have c2 times x, 2 times c2 times x, and on the right we have 0, so c2 is 0. When we look at k equal to 2, on here we have 3c3 times x squared, and on the right, of course, we have no x squared, so that's 0 as well. And so we found that c1 is 2, c2 is 0, c3 is 0. Now if k is bigger than or equal to 3, then we have terms in both of these series. And so what are the terms? We have k plus 1, ck plus 1 multiplying ck in the first sum, and we have ck minus 3 multiplying x to the k on the second sum. And of course on the right we don't have any powers of 3 or higher, and so we can solve for ck plus 1, bringing the ck minus 3 to the right and dividing by k plus 1, we get this. Or I've rewritten it here, the difference between this term, k plus 1, and this term, k minus 3, is 4. And so I've rewritten it in that form. If you move up 4 coefficients, you have minus 1 over m plus 4 times cm. And now here, m is allowed to be 0, 1, etc. And so that gives us a relation among the coefficients. Here's what we have. We're solving f prime plus x cubed f is equal to 2 with the initial condition f of 0 equal to 5. We were using a series, and we found that the first coefficient, c1, was 2, c2 and c3 were 0, and for m bigger than or equal to 0, cm plus 4 is minus 1 over m plus 4 times cm. Now because f of 0 is 5, the constant term is 5. And so the fourth coefficient is related by this to the 0th coefficient. And so that's minus, here m is equal to 0, minus 1 over n plus 4 is just minus 1 over 4 times C0. So that's minus 1 over 4 times 5. And then C5 is going to be related to C1. So that's minus 1 over 5 times C1 minus 2/5. C6 is going to be a multiple of C2, so it's 0. C7 is going to be a multiple of C3, so that's 0 as well. C8 is going to be a multiple of C4, and so we have minus 1 over 8 times C4, which was minus 1 over 4 times 5, and that gives us plus 5 over 32, and so on. Now, if you want to try to recognize a pattern, of course we can. Over here, every time m grows by 4, we're going to have minus 1 over another 4 in the denominator, and those are all going to be related to C0, and so we're going to have, if we have advanced from 0 twice, we're going to have 2 minus signs. We're going to have a 1 over 4 and a 1 over 4 times 2. So you can think of this as minus a quarter squared divided by 2 factorial. And so C12 will be a minus 1 over 4 cubed times 1 over 3 factorial. The next term here will be 12, and so on. And in the same way, you can also find a formula for C9 and C13 and C17 and C21, etc., all as multiples of C1. The factors are going to be going up by 4 each time over here. So they're a tiny bit harder to describe because, again, here we have minus 1 over 5th. The next one will have minus 1 over 9, and so on. Again, a little harder to describe that particular pattern, but there is a pattern. And of course, any multiple of 4 plus 2, the coefficient will be 0, and any multiple of 4 plus 3, the coefficient will also be 0.